Assalamu alaikum friends, this is Mohammad Inam, and in this video we have a really interesting topic, that is double Fourier series or Fourier series for function of two variables. Fourier series has a lots of application in physics and engineering. Using Fourier series we can extend our function, any function in our desired domain or finite domain. Such as wave equation, we can extend, we have a finite domain from 0 to L, so we can use Fourier series there to fix our domain. So in this video we have contains some initial results. For computing Fourier series we need some results. So first in this video we compute initial results, then in second part we will compute our Fourier coefficients for Fourier double series. So guys, if you like the videos, then don't forget to subscribe my channel. Thanks. So the contents of the video, the first part we need some initial result. The initial results are these. So first we guys compute these results, then we will start our Fourier series. If you don't interest in these results, so you can skip the video up to when we start double Fourier series. Before starting Fourier series, we need some initial results. So first of the result is, we need to compute this integral minus L to L sine m pi x over L cosine n pi x over L dx. We need to compute this result where for all m n belongs to integer. We need to compute this integral. So I'm using here trig identity, then that is sine alpha cosine beta equals to 1/2 sine alpha plus beta plus sine alpha minus beta. To compute this integral, I'm using this in a trig identity. So this will be minus L to L 1/2 sine m pi x over L plus n pi x over L plus dx plus 1/2 negative L to positive L sine m pi x over L negative n pi x over L dx. So this will be, if I'm giving, this will be pi x m plus n over L, and this will be pi x m minus n over L. So let R equals to pi x m plus n over L, and here R equals to pi x m minus n over L. So then dr by dx equals to pi m plus n over L, and here di by dx equals to pi m minus n over L. So this will be dr L dr over pi m plus n equals to dx, and here L di pi m minus n equals to dx. So I can put this both result into this integral, so I will get the result. This is L 2 pi m plus n negative L to positive L sine r dr plus here L 2 pi m minus n negative L to positive L sine I di. So the integration of sine is negative cosine, so this is negative L 2 pi m plus n cosine r negative L to positive L plus negative L 2 pi m minus n cosine I negative L to positive L. So changing the variable, negative L 2 pi m plus n cosine r. What is r? R is pi x m plus n over L. We need to put the limit negative L to positive L. And here negative L over 2 pi m minus n cosine pi x m minus n over L. Negative L to positive L. So theorem of calculus, we have result negative L of 2 pi m plus n. This will be cosine pi L m plus n over L, negative cosine pi negative L m plus n over L. And here negative L 2 pi m minus n, and again same cosine pi L m minus n over L, negative cosine pi negative L m minus n over L. So we know that cosine of minus theta equals to cosine theta. So this negative will be gone, this negative sign will go out, L cancel. Now this is cosine pi m plus n, this is negative cosine pi m plus n, so this is cancel again, plus minus. So we have negative L 2 pi m plus n times 0, and same here negative L 2 pi m minus n times 0. So we have total result is 0. So the first result is, if we integrate negative L to positive L, sine m pi x L times cosine n pi x over L dx will be 0. So this is our first result. Second result is this integral, guys. So first of all, this case number 1 where m is not equals to n. Case m is not equals to n. Again using trig identity, cosine alpha cosine beta equals to half cosine alpha plus beta plus cosine alpha negative beta. This identity will give us negative L to positive L cosine m pi cosine pi x m plus n over L, and half plus half negative L to positive L cosine pi x m minus n over L dx. So again this is R and this is I. We will have L over 2 pi m plus n negative L to positive L cosine R dr plus L 2 pi m minus n negative L to positive L cosine I di. Now integrating, we will get the result. Integration of cosine is sine R negative L to positive L, and this will be same sine I negative L to positive L. Now changing of variable, R equals to pi x m plus n over L, negative L to positive L. Here same pi x m minus n over L, negative L to positive L. Now using fundamental theorem of calculus, this is L 2 pi m plus n. This will be sine pi L m plus n over L, negative sine pi negative of L m plus n over L. The same thing here, negative L positive L 2 pi m minus n sine pi L m minus n over L minus sine pi negative L m minus n over L. So guys, we know that sine negative theta equals to negative sine theta. So this minus and this minus will be plus. Same here, this minus and this minus is plus. L cancel out, another result, sine n pi equals to 0 for all n. So this sine pi 0, this sine pi 0, this sine pi 0, and this sine pi 0. In the last we have find this result. If m is not equal to n, then this integral will be 0. Now for case number 2, where m is equal to n, then this integral will be negative L to positive L cosine m pi x over L cosine m pi x over L dx. So this will be square, and we to r equals to m pi x over L, then dr by dx equals to m pi over L, and d L dr over m pi equals to dx. So this will be L over m pi negative L to positive L cosine square r dr, or we can rewrite this one as L over m pi negative L to positive L 1 over 2 plus cosine 2r dr. So L over m pi negative L to positive L 1/2 dr plus L over m pi negative L to positive L cosine 2r dr. So here taking I equals to 2r, di by dr equals to 2. So this will be 2m pi cosine I di. Taking integration here, this will be L m pi half r negative L to positive L. Or here L over 2m pi cosine I, integration of cosine I is sine I negative L to positive L. So here replacing r to m pi, where r is m pi x over L negative L to positive L plus L over 2m pi sine I will be 2m pi x over L negative L to positive L. So this will be L over 2m pi and m pi L over L negative m pi negative L over L. So this will L over 2m pi, and this is 2m pi. So the result is L. So the result of this one is just L. Now I'm computing this, the second one. Here L over 2m pi sine 2m pi x over L sine 2m pi L over L negative sine 2m pi negative L over L. So L cancel out, and the same result last one. This is L over 2m pi, and this is sine 2m pi and negative sine plus sine 2m pi. We know that, guys, the sine 2m pi will be 0. So this part is 0 and this is L. So here we get the desired result which we want. Now the last part, if m equals to n and n equals to 0, this will be easy. If m equals to n and n equals to 0, then this will be negative L to L cosine 0 cosine 0 dx. Then this is negative L to L. Cosine of 0 is 1, so this will be 1 cosine 1 dx, and the result will be x negative L to positive L, and L negative L. This will 2L. So we get our desired results from this integral. Now the third one. The third one integral which we need. So first case, if m is not equals to n, then using trig identity, that is sine alpha sine beta equals to negative half cosine alpha plus beta negative cosine alpha minus beta. Using this identity, then this will be negative L to positive L, negative 1/2 cosine m pi x m plus n over L, negative 1/2 negative positive, negative L to positive L, cosine pi x m minus n over L dx. So again taking r equals to this thing and I equals to this thing, and then this will be minus L over 2 pi m plus n negative L to positive L cosine r dr, and this is positive L over 2 pi m minus n negative L to positive L cosine I di. The integration of cosine is sine, so this will be minus L over 2 pi m plus n sine r. R means pi x m plus n over L, negative L to positive L, and here plus L over 2 pi m minus n sine I means pi x m minus n over L, negative L to positive L. So here when we apply the limit in this L cancel out, and sine pi m plus n, again we know that this will be 0 and this will be again 0. So the first result is we have proved for true. Now for second one, case number 2, if m equals to n, then this will be negative L to positive L sine m pi x over L whole square dx. Now taking r equals to m pi x over L, then dr by dx equals to m pi L, then this will be L over m pi negative L to positive L sine square r dr. We can rewrite this one L over m pi negative L to L 1 over 1 minus cos 2r over 2 dr. So L over m pi negative L to positive L half dr negative L over m pi negative L to positive L 2 cosine 2r dr. So first this result I am computing first this result. This will be L over 2 m pi r negative L to positive L, L over 2 m pi, r is m pi x over L negative L to positive L, applying limit, then 2 m pi L over L negative m pi negative L over L. This L cancel out, this is L over 2 m pi, here is 2 m pi on the L. So here we get L. Now this result, taking I equals to 2r and dr upon 2 equals to di upon 2 equals to dr. So this will be 4 and this is I and this is I. Now computing this result, this will be integration of cosine I sine I, where I equals to 2 m pi x over L, limits negative L to L over 4 m pi sine 2 m pi L over L negative sine 2 m pi negative L over L. L cancel out, again sine pi 0 0. So here is 0. We have achieved our desired result. So these three integrals problems, why we solve, because we need when we compute Fourier coefficients, so we will need these results. So I have already computed. Now it is easy for me to compute Fourier coefficients. This is double Fourier series for function of two variables. We can represent any function by using this double Fourier series. So now we need to compute this Fourier coefficients a(mn), b(mn), c(mn), and d(mn), where the range of m and n, it's starting from 0 up to infinity by showing in their indexing. So first, if I'm supposing that n equals to 0, if my n equals to 0, then this is am0, this 0, this and 0, 0 and 0. So cosine 0 is 1, sine 0 is 0 and 0. What is the remaining part? We have left fx comma y equals to summation n equals to 0 up to infinity am 0 cosine m pi x over L1 plus cmn sine m pi x L1. So for computing am0, I'm just multiplying cosine s pi x L1 both sides. This is am0 cosine m pi x over L1 cosine s pi x over L1 plus cmn sine m pi x over L1 cosine s pi x over L1. Now integrating from negative L1 to positive L1 dx, and this is constant, this will be outside, negative L1 to positive L1, and here again negative L1 to positive L1 dx and dx. So the result we have found already from the integrals. We know that this will be 0 because of orthogonality, and the last result we have found. And now for this one, I'm removing this part. I cannot remove this one. So here we know that where m is not equals to s, this integral will be 0. Where m is equals to s, this integral will be L. So I'm removing my s from m here and here also. So now from the result we have found, this will be L1. The remaining part is negative L1 to L1 f of x comma y cosine m pi x L1 dx, and this 1 over L1 here equals to am0. So we have found our first coefficient where n equals to 0, m is not equals to 0. Now for second another coefficient 0, then series will be like this. Now we know that cosine 0 is 1, cosine 0 is 1, sine 0 is 0, sine 0 is 0. Now remaining part is the upper one. So for getting a0n, I am multiplying both sides by f of x comma y cosine t and t pi y over L2. and integrating from negative L2 to positive L2 dx. So this is constant, this will be outside, and this will here negative L2 to positive L2 cosine n pi y over L2 times cosine t pi y over L2 dy, here dy, plus here b0 n negative L2 to positive L2 sine n pi y over L2 cosine t pi y over L2 dy. Now guys, again we know that this will be 0 because of orthogonality and the result we have computed. Now for this one, if n is not equals to t, then this integral will be 0. So if n equals to t, then this will be L2. So I am replacing t by n here and here also. So this will be L2. So the result is 1 over L2 negative L2 to positive L2 f of x comma y cosine n pi y over L2 dy equals to a0n. We have computed another Fourier coefficient. Now guys, equals to 0 and n equals to 0, both are 0, then this will be a00, c00, b00 and d00, cosine 0 0 0 0 0 0 0. So sine 0, this term will be 0, sine 0 0, sine 0 0. Only the remaining part is this one. So I am just integrating 2 times from first negative L2 to positive L2 and negative L1 to positive L1 f of x comma y dx and dy, and this will be a00 negative L2 to positive L2 negative L1 to positive L1 dx dy. So from here we know that this will be a0 naught 2L1 and negative L2 L1 dy, and this will again 2L2. So a0 naught equals to 1 over 4 L1 L2 so this is our a0 naught. So if guys, if m equals to n is greater than 0, so first I am integrating and multiplying from negative L1 to positive L1 f of x comma y cosine m pi x over L1 dx. So if I'm multiplying, integrating from this side, let me show you amn, this is n pi y, so this is constant with respect to axis, so cosine n pi y over L2 here outside and negative L1 to L1 cosine m pi x over L1 cosine m pi x over L1 dx, and from here plus bmn cosine n pi y is constant with respect to x, so it will be outside sine n pi y over L2 negative L1 to positive L1 sine cosine m pi x over L1 cosine m pi x over L1 dx. Other terms will be 0 because of orthogonality, and this result will be just L1 and this will again L1. So we have the remaining, so the left one is will be AMN L1 plus L1 PMN sine n pi y over L2. So this is the result when we integrate and multiplying with cos m pi x from both sides. Now guys, again multiplying or integrating negative L2 to from L2, negative L1, positive L1, f of x comma y cosine m pi x L1 dx cosine n pi y over L2 dy from both sides. So if I am multiplying cosine n pi y integrating from L2, then this term will be 0 because we have already done this integral, and this term will be just L2. So the left part is L1, L2, AMN, and we just need AMN, so dividing both sides by L1, L2. So we have computed AMN also. So here up to guys, we have computed AMN, A0N and A0M0. Now up to guys, we have find all the coefficient which is related from A. Now we are moving towards B. So first try to find BMN where Mn greater than 0. So first I am integrating and multiplying with cos m pi x L1 from both sides. So this will be negative L1 to positive L1 f of x comma y cosine m pi x over L1 dx. So without multiplying and taking integrals, I am directly showing the result because I know that this is AMN constant, it will be outside. This is cosine n pi y, it is constant with respect to x, so it will again, and the integration of cosine m pi x L1 from cosine l pi x L1 from minus L1 to L1, it's nothing but L1. Same here, BMN is constant, it will be outside. Sine n pi y is constant, outside. And integration of cosine m pi x L1 from cosine m pi x L1 from minus L1 to L1 is just L1. And sine m pi x cosine m pi x integration will be 0. Sine m pi x and cosine m pi x integration will be 0. So remaining part is just this thing. Now I'm taking integration with respect to sine. So this will be negative L2 to L2, negative L1 to L1, f of x comma y cosine m pi x L1 dx sine n pi y L2 dy. Now if I am integrating with respect to sine, then this cosine and this sine will be 0. So no more this term and the remaining term, and integration of sine n pi y with respect to sine n pi y negative L2 to L1 is just BMN L1 L2. So just dividing both sides by L1 L2, and we have find our BMN. Similarly guys, you will find all the coefficients by using same technique. Let me show you the whole scenario. What about the Fourier series? We have find all the coefficients using some integral techniques or orthogonality property. So guys, if you like the video, then don't forget to subscribe my channel and kindly share this video from your circles, your friends. And inshallah ta'ala, in next video I have one example from function of two variable using Fourier series, that how Fourier series represent any function graphically as well as algebraically. Thank you.